begin. Welcome to the next session. I'm here with June P from Netflix. We've been talking about a project. We just got started without you guys because I'm pretty excited for this. He's got a project called Maestro that he's been working on, and I'm very interested to hear more about what he's been talking about. So with that, June, take it away.
Thank you.
June looks frozen. You're back. You're back.
Okay, cool. Thanks for the intro. Hello, everyone. Let me start to share my slides.
Perfect.
Great. Okay. Good afternoon. Hello, everyone. My name is Jun He, and I'm a staff software engineer in the data platform at Netflix. I have been with Netflix for over 6 years, primarily focusing on workflow and job orchestration. It's a pleasure to be here today to present our Maestro project. By the way, we recently made it open its source code publicly accessible. So yeah, you can play with it. We initiated the Maestro project about 4 years ago. We had an initial kind of internal alpha release in 2021, and then followed by a beta release in 2022, and then finally a general availability GA release by the end of 2022. Post GA, it took us another year to migrate all user workflows from the old workflow Orchestrator to the Maestro. Without requiring any code changes from the users. It's a fully managed migration. And then in July this year, we opened the public access to the Maestro source code. You can try it out after this talk. Hope you enjoyed that. We are still continuously adding new features to Maestro to enhance its user experiences. All the big data users and Netflix use it to build their data and ML workflows. You might wonder why we built yet another workflow orchestrator instead of using existing popular solutions like Airflow. Right? The decision was driven by the challenges we face at Netflix, particularly scalability, usability, and extensibility. So when we started the Maestro project about 4 years ago, scalability issues were not as apparent outside of Netflix. However, with the rise of AI and ML workflows, scaling issues in orchestrators have become more prominent. We have heard engineers and other companies talking about the scaling problems in the workflow orchestration system they have. Also, scaling is not only the number of workflows to manage in the platform, but also the size of a single workflow. At Netflix, a single workflow might consist of hundreds of thousands or even millions of jobs, which is common in machine learning model training pipelines or data backfill pipelines. We couldn't find an existing solution that could handle this scale. We had to go beyond vertical scaling to horizontal scaling. Additionally, supporting different integrations is crucial for an orchestration system. We designed Maestro to provide all the primitives like a programming language for users, allowing them to build high-level abstractions. For example, you may know Metaflow, right, which is another open source framework from Netflix for real-life ML, AI, and data science. That team developed a layer above Maestro for ML specific use cases. So all the Metaflow workflows run over Maestro. So we developed Maestro, a horizontally scalable orchestrator that oversees the lifecycle of workflows. Users can pack their code in Docker containers, notebooks, bash scripts, or SQL scripts, providing a serverless execution experience for users. Maestro supports both a cyclic and cyclic workflows. It offers multiple reusable patterns or primitives, such as sub-workflow for each and conditional branching. Maestro is also designed to be very flexible, including low-level primitives and or constructs, making it suitable for expansion and integration with other systems like a DBT Core or Metaflow. Before we dive into more details, let's look at a real-world example to understand how our users at Netflix build their workflows using Maestro. So assume we need to build a daily workflow to update a derived table for the total watch time for each active Netflix user. So we will create the workflow using the Maestro YAML DSL. First, we assign a unique ID to the workflow. Next, we define a workflow parameter called myQuery to hold the SQL statement we want to run, right? So here is the query always inserts overrides the past 7 days of data. It's because of the later arriving data. Finally, we then define a Spark job to execute this query. Then we save this and then push it using the Maestro command line tool, and then also run it using the command line tool. In the test run, we can use a dummy query, like a select one, to quickly execute the workflow end to end, making sure it works without running an expensive query on real data. Once it's done, then we can run it over the sandbox and then eventually deploy that to the production. Also, the command line tool will have a response, including the UI link of the workflow, so user can click link, go there, and navigate through it. It also returns the identifier of the workflow instance. In case if user want to build something around it, they can use that as a query parameter to fetch the data from Maestro API. After verifying the workflows manually, we can then add a cron trigger to schedule it to run every midnight in the Pacific time zone, for example. Maestro supports multiple cron triggers. Here I put 3. It also supports like a fuzzy cron, which helps reduce peak loads on downstream services or compute classes like a Spark cluster. But Maestro itself does not have a scaling problem. It just like add a fuzzy cron support here to spread traffic to reduce the burst traffic to the downstream system. Time-based triggering is popular due to its simplicity and easy to manage, but sometimes it's not efficient. Right? For example, a daily workflow should process data when the data partition of upstream is ready, not necessarily at midnight. To address this, Maestro also supports single-based triggering, which is efficient and accurate. It ensures workflows run only when necessary, saving resources. On the right side, we see an example. There are 2 groups of singles. The first group defines 2 singles, saying we want to run this workflow when table A is updated and also when table B has a partition update. We can also define or include join keys to make sure both singles contain the same value for those keys. These singles are published by upstream workflows when data is written. Additionally, user can define custom singles. This example says to run the workflow when an application, my app, allows a single ABC. It is available for any application that can emit singles at Netflix. Users can also carry actual data in the single payload and use it in the workflow. For example, here, a parameter called full is defined to reference the value of data interfered from table A single. But in many cases, users still prefer time-based triggering for various reasons. But it's challenging for users to ensure upstream table data is ready when the cron-based execution starts. So Maestro provides step dependencies or input signals to offer a gating function, making sure jobs run only when dependencies are satisfied. The workflow can execute until it reaches a job with step dependencies. Um, if those dependencies or signals are not satisfied, the job will wait. Uh, Otherwise, the job will continue and start run the Spark job there in this example. In our example, we define an input signal to wait for the previous day's partition of the source table to be ready before run the SQL script. So cron plus the step dependency together can also satisfy user needs to run their business logic once the data is ready. After the SQL script is done, right, the data is written to the table. The step can also emit signals to be consumed by downstream, either to trigger a workflow or to release a job that is waiting for this signal. This is a great way to orchestrate jobs and workflows in a distributed manner. Right, here I define an output signal trying to announce the data int to the downstream. Okay, now we are done. So we deploy this pipeline to the production and run it for months. One day, the finance and the billing department informs us of an issue that the table misses the watch time for many active users. What happened? Okay, how we discovered that the active users have the active flag set to be true or null, but we use like only true. So we have to correct that SQL query and then to the backfill, right? Run the backfill for the data. How do we handle this? Are we going to write a batch script and monitor it to run the SQL script day by day for the past 9 months? No need. Maestro provides great support for building backfill workflows. Here we use the for each pattern, sub-workflow pattern, and the cell expression together to build it. Right side is the example for the backfill. Here I define two parameters. Front date is the start date for the backfill, and to date is the end date. We use a cell expression to return an array of the dates for each step from front date to date. And for each step creates iterations per date, running up to 100 iterations concurrently because we define concurrency 100 here. We then reuse the daily workflow as a sub workflow to rewrite the daily data. You know that because the workflow is parameterized, so we just need to pass a date there to the our demo.pipeline. It will run the ETL again for that day. Internally, Maestro monitors the backfill progress, scaling out to different units of iterations and run them across the whole cluster. So users only need to specify the from and to dates, concurrency settings, and ETL logic. Here, ETL is wrapped in a sub workflow, which will run daily as well, plus that it can be used for the backfill. Okay, after the backfill, we should consider how to improve the workflow, so making things better, right? Although Maestro supports backfill, we don't want to backfill again and again, which costs money and time. At Netflix, our engineers develop a pattern called Write-audit-publish. Using Iceberg as the table format, so the workflow first prepares a new Iceberg branch. The user business logic writes the new data to that branch, get the actual information, and pass it to the user-defined audit job. Once the audit job succeeds, user can publish data by merging the branch to the main. Otherwise, the job failed, the workflow failed, and then Maestro alerts or pays the workflow owners as usual. So this pattern is very popular at Netflix. So we standardize it as a workflow template. Template feature allows users to define a set of jobs within a single template. So one template job, then you can put multiple configuration there. Eventually, at execution time, it fan out to 5 jobs. Instead of defining 5 jobs, user define this just single one template job. So first, put a source table here, then provide a write job, and which include the business logic to write data, and then define an audit job, which can audit the output from the write job. Here I also add additional job called VDTS to announce the output signal, informing downstream that the data is ready, either trigger or release the downstream jobs or trigger the downstream workflows. Yeah. So this approach works much better, right? But if something goes wrong, the on-call person has to manually fix it. Often, the on-call person has to take some predefined actions, such as restarting the workflow, or running a remediation scripts, or just take a look manually and then skip that audit, or ignore the error or something. Or they kind of use some way to patch data. But this puts a significant burden on the on-call person, right? Thinking about if they got paid at midnight. That's not a pressure and workload for the on-call. To reduce the on-call load and make the workflow resilient, we offer an auto-remediation pattern. So this diagram shows that. We run first the normal write-audit-publish pipeline as a sub-workflow. That's the sub-workflow job 1. And then it has audit job within it. So there's a check status job, which checking the sub-workflow status. If it succeeds, then it goes the upper branch to workflow ends normally. If not, it runs a recovery job. That recovery job can be the remediation script, something that the user have to manually run. They can put in here, and then rerun that pipeline again to see if it works. So is it complicated? Perhaps, but it is straightforward for Maestro users to create one. Here is the example workflow definition enabling auto-remediation. The first sub-workflow step, we use a step property called the failure mode to tell Maestro to ignore errors. So if the step failed, right, because the sub-workflow audit step failed, Maestro marks the step status as completed with error, but continues to the next step, which is a check status step. The check status step decides which branch to go using the conditional branching feature shown in this DAG block. You see in the DAG block, we have like a normal workflow goes to check status, and check status has like 2 branch. If otherwise, 2 conditions. In the if condition, it use the cell expression, load the status from previous step, check if it's completed with error or not, decide which branch to go. This if the sub-workflow fails, right, Maestro then runs the recovery sub-workflow step and then reruns the demo workflow. But this time, we don't set a failure mode. So by default, the workflow will fail if the rerun failed. User will then receive a notification alert. So on-call still got paid, but they got paid much less because the auto-remediation or the recovery job can handle a majority cases. Now this looks very good with a lower on-call burden. But we are not done yet. There is an efficiency issue in this pipeline. You might remember our demo pipeline, right? That SQL script has to reprocess the past 7 days of data due to late arriving data. And how can we improve this? We can use incremental processing support feature provided by Maestro. So Maestro offers two step types for incremental processing support. So that's the step. It's kind of general. It's a kind of interface. Depends how you implement it, which depends on the table format or the underlying like data lake system you are using. So here, this is based on the iceberg table format used by at Netflix. So the IP capture step captures the incremental changes, including the later data in the table since the last run, and provides a lightweight temporary table for users to use in their pipeline. This table is a zero data copy iceberg table. User can build an efficient pipeline using this change-only table. At the end, user can use the IP commit step to commit the checkpoint once processing is done. So you see here, the middle part is the auto-remediation, and then we just add the IP capture at the beginning and IP commit at the end. And then here is how it looks as a Maestro workflow. So I also add the description block in the workflow definition, which is helpful for workflow owners to include actual instructions, such as an inquiry runbook or some matrix dashboard or whatever. It supports Markdown, and so user can put many useful information there. Also, the description will be shown at the UI and also be included in the alerts sent to the users. So there's PagerDuty alerts or something, the email or the PagerDuty alerts will include this description as an instruction. And then we define a capture change step to tell Maestro to capture changes from the append only snapshots of the source table, and then include those data in a zero data copy table called icdc.membership_table.01. This table name is then passed as a source table parameter to the demo pipelines by sub-workflow step. So as you see before, right? All the workflows and Maestro is kind of parameterized. The source table is just a parameter name, which in the original table, that's the original table name. In this kind of incremental change table, incremental change processing pipeline, then you can pass that incremental that lightweight zero data copy table here to pass to the ETL, which doing the similar processing. Afterward, we then commit the checkpoint based on the IP capture step information. That's it. So I hope this development journey demonstrates how simple and powerful it is for users to work with big data using Maestro at Netflix. There are many complexities actually behind the scenes, which are transparent to end users. We aim to hide these complexities so user can focus on their business logic development. So platform can deal with all this. The example workflows have already demonstrated many key features of Maestro, such as sub-workflows for each and the conditional branching. We also showed how to use cell expressions to build parameterized workflows and use job and workflow templates for abstracting common patterns. Additionally, Maestro supports cron and single triggers as well as debugging and troubleshooting supports, which I will cover in the following slides. Let's first zoom out to see what we want to achieve, right? We would like to provide a workflow platform for everyone, including data engineers, data scientists, software engineers, and even non-engineers. It should offer polyglot interfaces, flexible integrations, a dynamic workflow engine, and extensible execution supports. Maestro covers all these aspects and has become Netflix data and ML workflow orchestrator. With all these features, Maestro has become very successful at Netflix. Thousands of internal users use Maestro to build workflows and run their jobs. Our users may have different backgrounds. Some write SQL, some write Python, some write Scala, and some don't even write code, and so on. Maestro supports all these use cases. The graph below show our current scale. The growth rate is high. We observe a significant increase every year. It corresponds to the new business demands. Currently, we run tens of thousands of workflows daily, with an average about 500,000 jobs per day, peaking at about 2 million jobs. The load is also uneven, which with kind of high spikes. Maestro is highly scalable and is able to schedule and launch thousands of workflows at peak moments, such as that first second every day at midnight. We also see many heterogeneous use cases. Maestro manages typical data pipelines. We also have a lot of AI ML workflows, such as Metaflow workflows running on top of Maestro. Some teams build specialized workflows, such as A/B testing workflows for experimentation. Other services even call Maestro to run asynchronous executions. Maestro provides a flexible, low-level primitives for data platform users at Netflix to build their own opinionated solutions to orchestrate their business logics. So abstractions are the key to be flexible. Using execution as an example, Maestro offers various step types of job templates. Those job types are built on top of Jupyter notebooks as templates. At execution time, Maestro injects user-provided parameters into the templates and then materialize that notebook. So advanced users can bake their own business logic into a Docker image or let Maestro run the image with a custom entry point, or they can bring their own notebooks to run. There's plenty of ways to run the business logic at Netflix. Each job runs in its own container, providing a clean and isolated environment. Here shows an example of notebook step execution. So we use something called Papermill, which is an open source tool that allows us to run notebooks headlessly without a notebook UI. So on the right side is a notebook output. At the top, there is a cell called parameters. This is helpful because users can see all the parameters injected into the notebook execution. It's easier for user to understand what's happening. They can also see the rest of code execution is readable, reproducible, and debuggable. A user can download and run the notebook locally for debugging. They can then update their workflow definition accordingly. Maestro also provides extensive execution control features. For example, users can control how many workflow or job instances run simultaneously. Users can also apply multiple tags to a set of steps or jobs to throttle them as a group. Maestro not only automates workflows but also gives user control over execution order through predefined run strategies. And here I list a few. Like a sequential is to run workflow one by one based on the first in, first out order. Strict sequential is similar, but it also handles unexpected job failures. In those cases, the workflow instance will only be queued but not be executed. First only is to achieve idempotency by skipping new runs if an existing one is running. Last only is to allow new runs to cancel the current running one, which is useful for processing the latest data. Parallel is allow multiple workflow instances to run at the same time. So providing debuggability and surface errors for users to troubleshoot is very important for improving user experiences. For debuggability, Maestro supports breakpoints to pause steps in workflows. It also surfaces error of information, execution timeline, and milestones to help users troubleshoot failures. Additionally, we build assisting functions in other services, such as error classification, alerting, and data feeds for analytical use cases. This separation of concerns makes the platform more scalable and robust. If any of these services are offline, the workflow engine Maestro can still run normally. To help users navigate workflow executions, we developed aggregated view and workflow roll-up features. In Maestro, each workflow instance is a group of workflow runs. So once a run ends, it becomes immutable. This is a very nice property to solve lots of challenges. Then when users click restart an instance, Maestro creates a new run by overlapping all runs together. We provide users with a mutable view of the workflow instance. Let's see this example. The first run failed at step 3. Then restarting it, run 2 consists of steps 3 to 5, right? Then step 3 starts, finish, and then 4 and 5. Then aggregating both runs shows users a completed workflow instance of 5 steps. If user clicks step 3 for troubleshooting, they can then get details of both attempts, the failed one from run 1 and the succeeded one from run 2. Also, additionally, with the sub-workflows and for each, the Maestro allows this kind of hierarchical workflows or workflow of workflows. It's quite a challenge for users to navigate, troubleshoot, and explore these complex workflows. Users often have to navigate multiple levels of workflows back and forth many times to understand what happened. To address this, Maestro provides a summary of all executions through the workflow rollup feature. So each step right, collects its execution summary. If it's a nested step, like a sub-workflow or for each, the step also includes its sub-workflow instance step information. So at any point, the step and the workflow aggregates the status of steps, like how many steps are running or failed and so on. Additionally, it can also include references like the links to the failed step. Then UI can render it and the user can easily navigate through. Every step does this in real time during execution, so the entire execution information surfaces from the leaf to the root workflow. Lastly, I would like to acknowledge the incredible teamwork of the Maestro team at Netflix. The team member names are listed here. That concludes my presentation. Thank you. Are there any questions?
There are. That was awesome. So if you, there's still some time to put some questions in the chat if you want. I've got a couple myself that I'm going to start with. Um, so so if you're on DBT, right? DBT Cloud, it has a scheduler. You can use Matillion to schedule jobs. So if you don't have experience working with Airflow or a different orchestration tool, um, this strikes me as kind of like learning. Like if you were going to learn to use an orchestration tool, starting with Maestro might be like learning to drive in a Ferrari. Is that fair? Like what
Uh,
would be if I want to learn to use, if I want to upskill, can I start on Maestro, or is there like another open source tool that I should maybe cut my teeth on and then step up to Maestro?
I see. That's a great question. Um, so from Maestro perspective, it's a actual orchestration system. It's an engine trying to power all the like uh, user business logic. So in that case, what kind of business logic you are writing is totally up to you. But
Mm-hmm.
then how you kind of deploy or dispatch that business logic, right? Which then depends on the interface, which is some user loves DBT, some to write that, some like to use Airflow, that kind of really nice
Mm-hmm.
Python annotating way to write those. So ideally, because Maestro is very flexible, it should be able to allow user to use any interface and then have a very thin translation layer to convert it from that opinionated approach or definition to the Maestro definition. And then from then on, Maestro can orchestrate that logic and run this logic. So so answer is yes or no. Yes is that it is a possibility to actually run whatever way you are writing or you're currently working, even like the Airflow workflow in all over the Maestro platform. No is that that a thin layer of translation is missing for most of parts. We have that internally for the DBT core, not DBT Cloud. DBT Cloud already have their
Hmm.
own
Right, not
solution.
DBT core. Right.
Yeah, only the DBT core, that open source one, we have a thin translation layer to be able to convert a DBT generated manifest file to a Maestro workflow definition. That's very straightforward. It's not a high effort. Similarly, for the Metaflow users use Metaflow syntax to write their ML workflows, and then Metaflow have a very thin layer translation to convert it to the Maestro workflow definition. Yeah. That's I see how even eventually for other orchestration system, like maybe user use Airflow already, you already have like thousands of workflows already defined using Airflow. You might be able to eventually deploy that to Maestro if there's a thin layer of translation.
And you, I was chat GPTing while you were talking because you triggered like a lot of thinking about this. So you might have spoken to this. Um, if I'm not Netflix, right? I'm not doing video, and I don't currently have millions of jobs that need to be run on a day. Um, I think one use case is if I want to start introducing some not machine learning, but generative AI workflows, that could easily um, require, the level of um, intensity that Maestro was built to handle. As a company, when should I consider, or maybe not as a company, because as a data team, right, as a data engineer, as a head of data engineering, when should you start considering implementing Maestro if your stakeholders are coming to you with um, something beyond just a toy AI request? Like they're coming with actual AI based projects, and you need to support some type of initiative, right? When should you start looking
I
at
see.
maybe adopting Maestro?
Yeah, that's a good question. In my opinion, I would recommend that even like day one, you should consider that, because as I mentioned, if you see the in the AI domain, right? Like for example, you would like build a RAG pipeline to ingest data to a RAG store. That is a data pipeline. You can easily use Maestro to orchestrate that.
Hmm.
And then once you have RAG, you want to like have your ML model serving part, right? Which you can use Metaflow. That is another open source project which can run everything over the Maestro. So Maestro actually can power that kind of workflow as well. And then eventually, in case you want to go more advanced cases, going with like a say agentic workflow, right? You want to have the human in the loop, and you want to run like a looping and keep like improve your answers. And then you can use Maestro as well, because Maestro support the looping like for loop plus that breakpoint. So you can actually pause in the middle and then doing that human in the loop thing to mutate some parameters and then resume it again. So I see that Maestro actually can power these three parts, which is can be very useful for even like AI development. So in that case, but I see that for the AI domain, lots of times, even setting up something like Maestro can be a still burden. So I see lots of users would like just run some script by themselves and move as fast as possible. That totally makes sense. But once you go to like production, right, you don't
Hmm.
kind of expect to run everything over your laptop. And then I see that's the moment that Maestro can be there to help users.
Cool. uh, it seems like Maestro is still task based versus Dagster, which is asset based. First, is that correct?
So yeah, that's correct. Like the Maestro, the workflow diagram is indeed the task or job based, but you see that we have lots of assets related concept like a step dependency and output singular, right? those things actually can be used to populate your assets or create a lineage between the workflows, which then can power them to doing things. So I think assets-based and job-based both have benefits and pro cons, and it depends in which cases you like to explore. But here I do see opportunities there that you might have like another assisting functions or services to doing the purely assets based, say asset store or something to keep states or
Hmm.
monitor those, which can bridge the gaps that Metro current does not have, but Metro is able to populate a single those assets information as a single back and forth to your service or ingest into the Maestro.
So for Netflix, when you were kind of making those considerations, um, so you were talking about like if you needed more asset based um, process, what were some of the kind of contexts and uh, and needs that you made the choice that you did?
So I think here for context-based thing, I would highlight here is that, as I mentioned, we are kind of very flexible. So we tend to first provide low-level primitives or constructs, which like singular those kind of things there, before we jump into some opinionated solution or something that kind of force user go with some approach or not. So that's like a similar, probably partially answer this question that we have that kind of basic primitives, and then we leave this space for users, or until we see some common patterns, we then raise the abstraction to provide some opinionated solutions built above it. So for now, we have something called memorization, which means that there's another service which can remember based on the address, which can be the singular reference or something, if this data sets or something address mapped data sets ready or not, to decide like if this job should reprocess the data or just use data already existing data sets and move forward. So the job can be skipped, something like that. There's something that around this kind of build about around it, but Maestro itself does not actually directly have that assets-based concept there. It's more like a use the singular trying to bridge that,
Cool,
which then make it very flexible.
very cool. I think that those are the questions. Any, if there's, I don't think there's any other questions. June, thank you so much for your time and for sharing. Actually, I did have one more question. Uh, I guess Netflix, you're the team, you guys, you didn't have to publish. You could have just used it for yourselves. I guess tell me a little bit about the decision to create a public repository. Um, how did you guys? I guess a little bit about the Netflix culture and your team. Like, how did you decide that this is something you wanted to do, and make it public and do it in public like this?
I see. Yeah, that's a good question. It's always case by case.
Mm-hmm.
Definitely Netflix is a company that has lots of open source projects. So company wide is actually
Mm-hmm.
lots of open source and would like to contribute. For our case, is like we develop Maestro and then have a great success internally, and then we also talk with some external users or parties, and then see there is a space or gaps there in the open source community. So we would like a contributor master there trying to kind of help open source or other users in case you can benefit from the master features, especially like those scaling thing and also the rich features or the low level primitives we provide. We hope that we can have a community around it, which then you can fork it and develop it and add your own opinion solution around it, trying to support your internal solution or something. Maestro is very flexible and it kind of provides this kind of low-level primitives. It's like a programming language kind of thing for you or for any developers kind of doing the additional development above it. So hopefully that can fill some gaps and provide also speed up the development, everything in this domain as well.
Oh, cool. Well, thank you again. This has been great.
Thank you. Yeah.
All right. With that, that's all. We'll see you guys.